Ciao Mattia.
Ciao Thomas, all good?
So far so good.
Yes.
So please, can you explain me who you are and what we're about to do?
Yeah, my name is Mattia Tombolan. I'm a Brembo race engineer for MotoGP. Now we are located in Curno, Bergamo, and today you're going to visit with me the racing department of Brembo.
Perfect. Let's go.
Let's go. So, nice to have you here.
Thank you.
This is our Brembo racing department for production, manufacturing. Here we produce all our parts for both Formula One and MotoGP, also for upgrade department. As you can see here, we have a small introduction of the typical component that we produce here. We have, let me say, an history of what was done before and what we have now. We have the example of F1 caliper, which sometimes it's very, for the client that came here, they would expect the Formula One caliper to be this one.
Yes.
So they always strange for them to see how little they are. But still, the braking torque they are able to produce is very high.
Okay.
Here we have an example of the actual Formula One brake disc. This is the one that we produce in the carbon factory. Carbon material need a specific range to operate with the correct friction coefficient. So you don't want your disc to be too hot or too cold. So you can manage the airflow going into the disc by, let me say, with the perfect. Also, the teams can adapt the different flow on the disc with specific cover, like more or less they do on MotoGP. I mean, of course, it's the weight is important, but if you compare the same disc made of cast iron, it will feel pretty much. So with this trick, we are able to put this kind of, let me say, technology also on street application. One of the reasons why we are here, let me say, of course, we are a racing department. We are following, let me say, every race, but still, we are part of a very big family. So part of our, let me say, our goal is to, let me say, test new technique, new technologies, and try to bring this to the street application. This is the MotoGP caliper, the same that we are using now. This is an example of the Moto3 caliper. We don't have here the Moto2 caliper, but you will see also the fin, also Moto2, Moto3. And this is very important for us also because, you know, compare jumping from MotoGP to Moto2, Moto3, also the rider that make the jump very often tell us this, that the main difference is the braking.
And when you compare MotoGP to Superbike caliper, you have less need of cooling because you have less energy dissipation, correct?
Yes, correct. Also in Superbike, this is the old one. We have the new one, which is very similar to the Moto2 because as category, we see that there are some area where they are, let me say, in the same area. And of course, the energy that they have to dissipate is less, not actually that much less if I look at the Superbike, because sometimes the energy are pretty much in the same, let me say.
Can I take one of these discs to weigh it?
This type of configuration is not in use anymore now in MotoGP because it's not, let me say, with the increase of braking effort that we have seen in the past years. This is not enough to dissipate unless we are running in Phillip Island with rain condition, where we have a specific type of disc.
And you also produced it's like magnesium wheels?
Yes, both aluminum and magnesium. For example, in Superbike we are using aluminum, and in MotoGP, but also Moto2 and Moto3, we are supplying magnesium wheels. Still, this is very light. When you move to this kind of aluminum forged wheel, the gain of weight, the reduce of weight is between 15 and 20%. When you move to magnesium, we are moving to 30%. Of course, we are missing the internal part, but
this is so light.
Moving from this to this, we were able to save also much more weight. We are always talking about hundreds of grams, of course, not much, but in racing.
And this architecture allows you to...
you anticipate me? When you are able to reduce the weight on the external part, where the radius is, let me say, higher, you you have a much more, let me say, important effect on the drivability of the bike, because the inertia of the disc of the wheel increases much high when you have a lot of weight on the external part. Here you see an example of the, let me say, original material as we receive it from our supplier.
Aluminium?
It's aluminum alloy. It's a little bit different from the Formula One because of the regulation, because there are certain, let me say, components that are not allowed in MotoGP.
Can I take one to have a look?
Here you can see from one you can get almost one set of calipers, so right and left. The machining operation involve different machines. You cannot do just in one machining all the parts. One specific that we develop in Brembo is the machining of the
much better, much better.
See, the most tricky machining is the groove for the seals of the pistons, because it's internal. So we develop with our supplier of the machine, because also the geometry of this groove is very important for the performance of the caliper. If you're working with carbon material or steel, this groove will have different geometries. And here you can see the initial machining of the MotoGP, not MotoGP, but of the caliper. It's pretty nice because you can see that we are starting from the block of aluminum that we saw before. And here you have the initial phase where you start to see the actual phase of the final form of the caliper. And after this, there will be a quality check. And if the material is, let me say, approved, it will go to the second finishing operation. And after that, we will go to the other department that we will see later on, where you have the assembling. This is reserved only for machining.
But this is constantly water cooled for the parts not to be...
Yes, for sure. The cooling is, let me say, not only for cooling, but also to take away the machine part away as fast as possible from the final part. Of course, this is called the racing department, but as you can see, there is also the machining also of upgrade components.
They do the same at Michelin, where they do the T3M for the MotoGP prototypes. It's also the high-end tires for Lamborghini, Porsche, Maserati, same type of organization.
Because our, let me say, our target of quality is more or less the same. If we are talking about high top ranging models, we still want to have them the best material as possible.
Yeah, so you use this as R&D for your top-end product.
Correct. Here you can see the medium phase between the beginning part, the block of aluminum, and the final part. This is the, let me say, in between. When you have the first machining, you machine your reference, which are these two blocks that will help you for the next machining. So we'll use what you have done in the first part to fix the part for the next. This is the, let me say, what comes from the foundry.
Yes.
As you can see, the look is from, let me say, raw part. And after that, we fix on our machines, and of course, we machine all the cylinder and all the fixing for the lever.
So when you're machining, the treatment changes, so it's a loss of weight or it's a different rigidity? What are you trying to achieve with a different machining?
Of course, we try to optimize the stiffness, because when we're talking about braking, it's always the rider that is putting an effort to apply a pressure. If something in the braking system is bending or it's, let me say, pumping, it means that the power of the rider is being, let me say, absorbed by another component and not going to the disc. So it's not actually putting torque on the. So we always try to balance the stiffness of everything. Our carbon factory, our latest building here in Curno, was built in 2018.
Yes.
Start building. The latest finished was in 2020. This facility is dedicated for our carbon material production, both disc and pads.
Okay.
The production process involves different types of oven process phases, which require a lot of time, and we are between 7, sometimes also 8, 9 months.
Okay.
But not only about oven, but starting from here to the finished disc, also machined. Here you can set different shape and sizes depending on the application. This is the, let me say, the intermediate phases. Then we have the machining, which unfortunately we will not see now, but the result is what you saw before. You need to machine not only the holes, but also the fixing part for the bulb, in order to be able to fix the disc to the bike or to the van.
Wow, how complex.
Here we have the Marchesini department.
Yeah, yeah.
So here we produce both aluminum and magnesium wheels. Yeah. One thing that is very tricky is the machining of magnesium.
Yes.
As you know, it's very, also the hazardous is very high because magnesium is a material that tend to, let me say, burn.
Okay.
So you need to adapt very in the correct way the machining parameter in order to get the perfect result. Here we have the quality department, which is used not only to, let me say, the approval of the batch that has been produced here and moving for the final part, which is assembling, because of course here you have the master cylinder, the caliper, the body. You still need to mount the pistons, the seals and everything. As you can see, there are different type of probes, the dimension. This, on the actual measurement, will feel like a filter. If the dimension of the sphere is higher, it will touch more the peak of the material easier, so it will act like a filter. If the probe is little, you will see more easy the, let me say, the roughness of the material will have a more effect on the measurement.
So you can control everything?
Yes, exactly.
Okay. With this you control and you rotate?
You rotate every time while rotating you're still continuing to acquire images, and by applying this on here, when you rotate the machine still know that this point was before here.
Okay.
So as soon as you move, it will, let me say, rebuild the reflection of these parts on the computer, and you will gain a, let me say, an external surface of what of the component.
So then, thanks to this system, you know that the machine has been working, respecting perfectly the 3D shape that has been calculated by the computer to...
Correct.
Okay. So you have a before and after.
Yes.
Grazie, signore.
Prego. So here we are in our experience department. Okay. Here we have a little, let me say, brief of the typical component that we have, we manage here. Mm-hmm. This department is, let me say, focused on replying the environment that we see on track. Okay. And reproduce as much as possible the performance that we will see actually on the track, in order to, let me say, anticipate what the rider or the feeling will be on the track. Okay. So, for example, here we have different application for Formula 1 cars. Yes. What is pretty clear as soon as possible is the, let me say, how much in deep our designer went for the heat dissipation of the caliper itself. As you can see here,
it's a lot of fins.
A lot of fins, and this is specific for the race application in Formula 1, when you can also tune the heat dissipation on the actual pistons. Wow. This is the high mass fin.
Yes, okay.
So this is the, looking at the, I think it could be also the 355.
Yes. So the Motegi, Red Bull Ring.
Yes.
I heard that to build this type of disc, it had to stay for 6 months in the oven. Is it correct?
Correct, yes. The carbonization process, which requires specific time and pressure in a specific atmosphere of carbon, is pretty long to reach the correct densification, as we see, of the material. And after that, also you have to machine the part to obtain the fixing point for the bell, and also the fins.
Which is the material for that?
Aluminium.
Aluminium, okay. Wow. And the play, this is normal that you have some play, so that is it's well centered when the pads attack the disc?
Okay. This, let me say, free floating
Okay.
is to adapt the
Like 1 mil, something like that?
no, it's less. Should be around 0.5 or 6. It's a little bit less compared to the steel disc because, of course, the thermal expansion of carbon material is way much less compared to this.
Yeah, of course.
This is for actually this is a superbike. You are able to distinguish superbike and MotoGP from the presence of fins in MotoGP both
sides.
both sides.
Yeah.
Superbike and Moto2 are this kind of layout.
It looks like a piece of jewelry.
Yeah.
Wow. So this is pressure in, pressure out? Or?
This is pressure in, and this is just for the bleeding.
Yes, okay, I understand. And why the QR code here?
This is the anti-bribery code because we have this kind of problem in different market, especially in the Asia market, Asia. There is a lot of artifact of Brembo caliper.
Okay.
This is for the, let me say, to reduce the residual pressure of the bike. When you release the brake,
the paddle
will immediately, let me say, move away from the disc and reduce the residual torque and also the possible heat increase due to this, let me say, residual torque.
Beautiful.
This is the master cylinder that we use for MotoGP.
Yeah, wow.
But the great majority of teams use the, let me say, sensorized master cylinder.
What do you mean?
Where you can acquire the position of the lever.
Yes, okay. Like 2D, they have they know how much course of the lever they use.
Yes.
Depends on the race. If can show you if the stability of the system.
You can let me say match the data from pressure and the master cylinder, and let me say try to interpret the feeling of the rider.
When the rider brakes, it sends fluid from there to the calipers via this hole.
Okay. Yes.
Okay,
Exactly.
Yeah, okay.
Will be.
And also you need certain rigidities not to have any loss of pressure.
Exactly.
It's what you explained.
Yeah. If there is some bending of this component,
yes,
it will mean not only that the rider could feel some, let me say, strange feeling because if it's not perfectly centered, it will feel like a resistance to the movement. So this need to be exactly centered. Also, we have a very tight regulation for how much you need to close this screw.
Okay,
otherwise, it will, let me say, bend the master cylinder.
Yeah, okay.
We are always talking about efficiency and stiffness, but actually you need to, let me say, match the feeling of the rider because one rider could feel like it's too stiff.
And would you say that it's tailor-made for every rider that you work with, or that majority of
I think
riders?
the majority is working with one spec.
Yes.
And then maybe we have the 10-20% of rider that use something
special
different.
needs. Okay.
Welcome to our testing department.
Grazie mille.
It's always a pleasure. And you can see we have the different bench, the dyno bench. But for this explanation, I will introduce to my colleague, Francesco.
Ciao, I'm Francesco, and I am in charge of dyno testing here in Brembo Performance. And now I can show you what we do here to test a MotoGP brake system. You can see here Brembo MotoGP brake system.
Yes.
And we need to characterize them in order to map the friction performances, and also in order to validate it from a structural point of view.
Okay.
We need to work with a high safety factor. So usually, what we do here, we apply the strongest track.
Yes.
For example, Spielberg. We can apply Spielberg replay. We apply the torque control and the pressure that the driver is actuating in order to match the right temperature of the components of the disc and the pads. And we want to see how the system behaves in terms of wear and in terms of friction performances.
Okay. Thank you so much.
You're welcome.
Welcome to our assembly department, the final line where all the parts that have been machined before in the department that we saw in the beginning are finally controlled and assembled. This is not only dedicated to racing department, but as for machining, also the upgrade department is assembling parts here. Of course, the huge difference is the volumes of parts. When you're talking about racing, you're talking about hundreds of parts.
Yes.
When you're talking about distribution, final, let me say, customer street application, you're talking about thousands.
Okay.
Here you can see also our latest upgrade, which is an automated warehouse, which helps us to, let me say, increase the efficiency of all the system. Here is also the department where we overhaul the MotoGP and Formula One material. When it reaches a specific mileage or overheat or after a crash, is sent back to the factory when we check everything with our parameters, stability of the process, and we change, for example, the seals, and then it's sent back to the team. So this is where we assemble the F1 and MotoGP caliper. So the parts start here, they are disassembled. All the single parts are checked individually. Yes. Then there is the, let me say, the cleaning operation, and finally the reassemble with, let me say, new material and everything.
Okay.
Of course, at the end, everything is tested in order to keep it, let me say, ready to use for the final customers.
Ciao Daniele.
Ciao Thomas, how are you?
Good, and you?
Fine, thanks. So, welcome in our global headquarters of Brembo, located in Stezzano, inside the Chilometro Rosso. You are here because I would like to show you our first museum of Brembo brakes, that is called The Art of Braking.
Perfect, let's go.
Yeah, sure. So, the 1961.
Okay.
In this year, Brembo was founded by Emilio Bombassei, and in front of you, you can see the first plant, the first entrance of the factory of Brembo offices, and you can see how much is different respect today entrance in Chilometro Rosso. Brembo arrived in motorsport in 1975 with the first application in Formula One to Scuderia Ferrari. Okay. After this year, after this event, Brembo came in a lot of motorsport competitions, like MotoGP, like World Superbike, Formula E, Moto2, Moto3, and some other categories. And we are already in almost 50 years of motorsport, because in 2025 we celebrate the 50 years of motorsport. You see on this circle table a lot of materials that we use to produce our discs. And you can see here all the discs that we produce for application, that are racing application and original equipment application. This incredible and wonderful wall is a wall that represents our offer in terms of colors to our customers. They can choose what color give to the car in terms of caliper color or on the motorbikes. On the left, you can see our amazing wall with our products, with our braking system and all our colors for calipers. Thomas, thanks for your time. I hope that you and GP Mag fans enjoyed today in our racing plant in Curno and in our amazing global headquarters based in Stezzano. See you in Mugello.
Absolutely. Ciao Daniele.
Bye.